Hello, everyone. Thanks for joining us. My name is David Leclerc. I'm the host of the ChUG podcast. I am a technical director of the CAT facility at the University of Chicago. I'm here with Ryan Duggan, who's the scientist at AbbVie. I forget your exact position, senior scientist or?
Actually, somewhat recently, I'm now a principal research
Ooh,
scientist. So,
congratulations.
thanks.
Nice. Also joining us is Mr. Bill Eads at Washington University School of Medicine. Thank you so much for coming.
Absolutely.
And Dave Adams at the University of Michigan runs the core facility over there. Hi, Dave.
Hi.
So, discussion today, we're kind of revisiting another podcast that Ryan used to run called Cytometry on Air a while back, and he basically ran a similar discussion with Mr. Dave Adams and Phil Exley, who disappeared somehow, and exactly on the same topic, cell sorters. We basically covered the field and we discussed what was around. And I thought we'd revisit this topic a bit because of an email that Bill sent out back in June. I think it's going to taint whatever we're going to discuss today, but I still want to present an overview of what's available on the market and how to think about what's needed in your core facility. And so to launch the discussion, I guess we should talk about the state of the market or the way I see it. I'm somebody who's been trying to replace my Arias. I'm definitely not alone in this field. I think everybody bought their Arias pretty much at the same time. And you still hear a whole lot of people trying to replace their Aria 2, which is no longer supported. And we're looking at what's available in the market, and the solutions that are proposed are somewhat it's a scary thought to have to spend a whole lot of money on instruments that do not have the best of press right now. I should start discussion by asking you guys where are you in your quest for buying instruments? Are you currently looking for buying a cell sorter, or is that something that you're good for now? Or start with Ryan, or let's start with Dave.
Sorry. No, I was just going to say we just replaced our last Aria and are looking for a replacement for our final Astrios. Coulter's complete exit from Astrios, any meaningful Astrios support, has really impacted the lifetime of those instruments quite unfairly to the consumer, if you ask me. But they're all in on, CytoFlex platforms now. And, even though we have dollars invested in this Astrios platform, we can, it no longer makes any sense to keep it on campus because it's incredibly unreliable. The service engineers can't fix it, that sort of thing. The BD direct Aria upgrade path has some issues. You could, of course, replace it with an Aria Fusion. The problem is with their S6 and S8 platforms, yeah, I could buy an Aria Fusion today, but how long are they actually going to support it? They're kind of close-lipped about that sort of thing. The S6 launched and was fraught with issues, trying to adhere to the Diva software, for a spectral instrument. Has essentially resulted in people buying a spectral instrument but not using spectral, not to mention the terrible rollout of their new ACDU. And then the S8, which is, I did eventually buy an S8, which is an interesting platform.
What about you, Bill?
Sure. I mean, our flagship is 23 years old. It's a MoFlow HTS legacy.
Nice.
That we've hot rodded. And our reason why it's flagship, it is the most gentle on ourselves. We really dialed in how to use it for that purpose. And it has one of the most reliable plate deposition units that's ever been built. It's difficult to keep going. It's the hardest thing we ever do, to keep a cell sorter going for 22 years. We have two Arias that we did not buy new, that we've obtained and upgraded. We have changed the configuration greatly. All 18 colors work, but we have 6 off of violet and 5 off of UV, just to try to keep the technical relevance intact of these. And Aria platform is pretty easy to deal with as far as working on them yourself. I think there will not be a parts shortage for Aria because it was the largest selling cell sorter in history. And I think there's a lot of good third-party options for that. So we're keeping those going. We've got an Aurora CS, and I've got a Sony Synergy 2 HAPS, 2 sort modules in one 5-foot biosafety cabinet. And we've updated that, and we're sort of wondering when these companies are gonna cease support all around, and it's unclear. And I think that's a large topic of this, but we understand that we're dealing with legacy instrumentation for the large part in a core, and we've got a pretty decent track record in doing so. A lot of that, frankly, is because I'm an old field service engineer from both Coulter and BD, but I've taught everybody that works for me how to be self-reliant, and even people in other academic centers and so forth, and it seems fulfilling. And so I mean, that's what we're doing. As far as looking for new cell sorters, I'm looking more towards microfluidic, and a lot of it has to do with this whole idea of, as Peter Lopez would call six, the fact that we're killing things. And I remember when the MoFlo first came out, everybody ran it at every high speed it could do and killed everything. We did for 4 months. All we did is kill stuff, and we learned it. We figured it out. I think there is going to be a place for a highly dimensional microfluidic cell sorter. It's not here now. Most of the companies are dipping their toes into this, where I think at Miltenny, they just latched on a max quant to make a Tyto. And I know, so honestly, some things seem to be the future that we can peer into. One seems to be spectral, one seems to be microfluidic.
What about Ryan?
Yeah, and unfortunately, my high-end sorting needs are pretty minimal.
Yeah.
So I have an Aria Fusion that's pretty much fully loaded for doing lots of cell line generation, right? So we're basically sorting a lot of, GFP variants and red fluorescent protein variants. And the Aria that we have, although, very capable and functional, is, about 8 years old now. I usually start thinking about replacements at about 8 years is kind of the start of the process for me. So we've been actively looking at lots of sorters and trying to test as many things as we can, both on the very, very low end, and some of the ones that have already been mentioned. So I guess part of my decision-making process right now is, do I want to, maybe try and buy something that is very specific to my needs currently, a la, making cell lines, in which case that would dictate my choice pretty dramatically? Or do I want something that's maybe a little bit more fully featured and capable to handle the science as things change? And I'm not a huge fan of I don't know if you guys ever watch any cooking shows at all, but Alton Brown, he's like one of my favorites. Yeah. He has a distaste for what he calls unitaskers, things that obviously just do one thing, but might do it pretty well. Yeah, I mean, I don't know if I'm looking for a sorter that is a unitasker that's just going to, either clone out GFP clones for me or, just handle my low dimensional stuff. Um, I would like to get something that's a little bit more full featured, but the price tag of that gets pretty large pretty quickly. So yeah, I mean, I'm definitely in the market. So happy to hear all the things about the new sorters coming out today. Um, and yeah, still trying to find that sweet spot. I mean, I guess I do agree with Bill. Kind of the whole microfluidic angle is very alluring for the gentleness that it might exhibit on the cells of interest for both like cell line generation as well as single cell RNA-seq and other kind of in vitro assays that might be happening.
Yeah.
How about you, David?
I am trying to replace an Aria 2, and our core facilities, the general idea has pretty much always been to future proof our purchases. So buy something that will do everything for everybody for as long as possible. And the solutions are just not great at this time. But I've also started looking at, okay, where does, thinking about these workflow in science, where does cell sorting ends up, and what are where are the cells going afterwards? And so what's the quality of the cells that we should have at the output of a sort, so that the following experiments are going to be maximized. And so that's where I've been saying good things. I can't shut up about the Tyto. So I've the general idea of microfluidics, the different ways of manipulating the cells that will keep them as happy as possible is coming from. But I think it brings, and here we're just gonna free flow the discussion. So jump in whenever you want. But I think there's two general ideas two general features of the market currently that when you make a selection of cell sorters that you should take into account, or you should be aware that it's a thing. The first one is a bit what Ryan was saying. There's more and more of these single task cell sorters. I call it the cupcake effect. I'm in vacation in Quebec. I just went to a beer store, and there's beers about everything. There's a guy who put carrots in his beers, and then it's like, why did you do that? It's just a gimmick to become like a little bit different. And so like back in the days, we had like you would buy the MoFlow Legacy, you would buy the Aria, you would buy the Influx, and they would essentially do the same thing. You have the same range of the nozzle tips, the same detectors, the same lasers, and so you could basically jump from one another and kind of get the same results. They were all basically doing. Nowadays, like everything is focused, and so you have the Tyto that does sterile sorts, and you have the CytoFlex sorter that is for easy to use, but it's limited to one single nozzle tips. And then you have Dave gave me a look earlier, but when I talked about the S8, that's one designed for imaging. So there's like, in my view, some limitation about the way it was built that will prevent it from acting as, say, the Aria does. So anyway, that's the one thing. The second one is, it seems none of the instrument that comes out of the market are ready to go. The Bigfoot is the child poster example of, is that a thing? Child poster? No, it's not.
Poster child.
Poster child. Hey, there you
yeah,
go.
you're close. Probably in French, it's child poster.
Exactly. Well, it's not even an expression in French. But the machine came out and just not ready for the market, and just we're still messing around with upgrades and whatnot. You hear of, I've not seen it myself, but the Cytek cell sorter, from what I've heard, seems to have issues as well. it seems that all the machines that are pushed on the market are just not quite there yet, and it's like Bill said, just quite a bit of time to get the instrument ready. So let's start with that, and then once we're done with these 2 points, we'll talk about actual machines.
Well, I mean, those are really two different questions.
Of course.
Machine functionality, what it's supposed to do, and then the state of machines as they're being delivered to market. On the one hand, you have, I tend to think of sorters as Ryan said, unitaskers, mid-range sorters, and then high-end sorters. And the high-end sorters on the market, the Bigfoots, the S8, the S6, are all fully featured, capable instruments, not tied into any one particular task. Whether or not they currently work well is another discussion. And then there's the issue of manufacturers announcing machines 1 year, 2 year, 3 years before they're actually on the market. When they come to market, we're essentially doing generously beta tests on the unit. And the fact that, we as the cytometry consumer have put up with this over all these years. Back in the old days of the Star Pluses, the Vantages, we were starved for any sort of innovation. The only time a company would innovate is if someone new showed up on the market and introduced features they didn't have. So, why did the Star become the Vantage? Because the MoFlow was on its way. Why did we, end up with, the Astrios and those sorts of things? Because of the push of, smaller players coming into market and offering things. And we were happy to beta test because we needed to push the science further. We were very limited by the tools we had. But that cooperation between consumer and manufacturer has really been abused and pushed to the manufacturer's advantage these days, where they are happy to drop off a piece of equipment and say it will work fine eventually. And of all the instruments I bought in recent times, there's only 2 that have landed doing exactly what they're supposed to do, and that's the ID7000 and the S8.
Mm-hmm.
Those are.
Oh, go ahead.
Well, I just want to follow up on Dave's comment. That's, did you say that the S8 and what was the other one you said?
ID7000.
ID7000.
Oh, okay, 7,000. I mean, those are maybe a little bit more recent. So do you think the problem is getting better, or perceived issues getting better? Or I guess the ID7000 not that recent. That one took a long time to come out. So
yeah, I don't know that the problem is getting better because, again, when did BD announce the S8? 2 cytos ago. And when they announced it, it was, hey, you can do imaging along with all the fluorescent channels. Then it became, you can do imaging on the blue laser channels. Then it became, you can do imaging on 6 of the blue laser detectors, whatever 6 you want. Then it became, oh, actually, there's 3 imaging channels off the blue laser, which we're splitting, but it's 6 channels because, there's scatter and light loss and things. So again, they were announcing a product before they even really had a strong idea of what it was. And they did do alpha testing with some people in the field, but that machine really was an imaging-based cytometer, whereas the S8 is a spectral cytometer that has some interesting imaging capabilities as well.
So the other part of this that you mentioned 2 issues about marketing and launching and so forth. I have a third. The third is the simultaneous forced obsolescence of perfectly well operating platforms. That there is no transitionary period that is really satisfying the user base. It's this all or nothing. You either have to buy something new or you will forfeit support on something that you want to keep. And I think, I mean, I overuse this mantra, and I've done it for decades, that, it's vendors driving science when it should be the other way around. And this is really emblematic of that, that you should maintain support for as long as it takes you to get a launched product to its absolute sellable performance. And I say sellable performance because a lot of people have had to launch something with a myriad of features and then step back and say, well, we really can't do this and we really can't do that. And then it ends up being a diminished piece. And I have to say Bigfoot. I had one. I don't have one now. As far as what I feel is going to be a continued problem is third-party service being armed to the teeth with enough really good engineers and coverage throughout large territories when normally they're localized in a region of a country. I mean, Cytek for the longest time was a pretty decent, almost worldwide third-party service company for BD products, and then all of a sudden that quickly curtailed. And then if we have options, and I'm trying my best to support any of the third-party vendors that are there with everything that I've ever collected and methods and documentation or anything, just to make sure this doesn't adversely affect people trying to make a decision that's not wonderfully funded to do so. I mean, the larger centers in the United States, they're on cycles that are, 3 or 4 years, and they've got enough to really purchase something, whether it be on S10 grants or whether it be just internal with the institutional money. But not everybody has that, and there's attempts for a lot of companies to make smaller products that a chicken in every pot, and you go for the smaller customers and everything. And that discussion we had about, well, what do we want? Do we want a one-trick pony, or do we want something that'll do everything? Well, the cores, the shared resources of the large academic centers and industrial centers, they want one widget that can do everything, and as much as possible, because they're going to be called upon to do everything as much as possible. And that's getting more and more difficult, in that a lot of these promoted features don't work at point of launch, and the customers want that to happen. And then you have to say, okay, I guess we're going to help this company develop this. Then there's companies that are willing to let you help develop, and there are other companies that are not willing to let you help develop. And I got to say, I got to throw Cytek a bone here. They've been very interactive. They've been very receptive. I didn't expect it, frankly. But David Vrain's been very approachable and accountable. And we waited like 6 months. We actually paid for a CS, and we didn't take delivery of it for 6.5 months because we wanted something that would work out of the chute. Now, did it? Kinda. I mean, mostly. But the fun part is that it's been a continuous improvement quickly. And there was one thing that we wanted out of this. We wanted, with a large academic center, Washington University School of Medicine, that has over 30 spectral analyzers in different private labs and different departments. They're all craving for cell sorting. We could never even close to translate these panels from auroras and northern lights to a Bigfoot. We can with the CS. Mm-hmm. We do it all the time. It's turnkey. it's the first success that we've had in this high dimensional flow sorting in a long time. So, I mean, no one's paying me to say that, but I was
Well, I mean, it was designed to do that. Cytek built the Aurora, the Northern Lights. They built the sorter. It's the same optical deck, so it's a rare example of intelligent design within.
It's a very different instrument. You got to think about something, Dave. All of the Auroras and Northern Lights are vacuum-based systems that with, you know, a certain event rate and a certain time of flight that has to happen, right? They flipped that to a pressure-based system and made it work. I'm sorry, that's a freaking miracle. I mean, and to make it work as well as it does. Now, do all the features work well? For the most part. But I mean, is this a sorter that everybody should get? No, because it doesn't apply to everyone's needs. It applied to ours. But we're still looking for instrumentation to replace aging instrumentation that we may not be able to maintain and keep going for a while. I got a MoFlow that I bought in 2001. Yes, it's in daily use. It's not always going to be like that.
Well,
But the controlled obsolescence is what I'm really adverse to the most on behalf of these companies. They don't have to be that way.
I was about to ask, like, what's the path for somebody who's listening to us who would like to replace their instrument but can't find fundings? They'll just have to get the whatever they have going. Where do they turn to make that happen? If the service contract is out, if this company no longer supports.
A lot of it is who they communicate with. If they are communicating solely with the vendors, then yeah, they're going to be distraught because they're going to be painted into a corner of buying a new instrument.
Right.
If they do look at the Purdue listserv and things and realize that there is thriving third-party activity going on, and people, not just myself, but others that are willing to interact with these people and teach them even more and get them into even more platforms that there were a lot of. Because that's the other thing. In order to be successful in third party, there has to be enough there that have been sold for seed stock to go scavenge and obtain. And there are some platforms that won't have a chance. I hate to say it. Astrios won't have a chance. There weren't enough of them made and distributed for them to be sustained. But I mean, XDPs, Arias, yeah, those can be maintained.
And eBay is your friend. People are selling scrap Arias, scrap XDPs, legacies all the time on eBay for, a couple $100. You can pick up a carcass or part thereof. So boards that you can't get anymore, you can just, buy a husk and scavenge. Aria parts you had mentioned earlier, you don't think there's going to be an Aria part shortage. I have had to resort to the, third-party obsolete chip market many a time to repair some of the boards, and because, the boards aren't available. The chips are no longer made, but, you can find that Russian vendor who has a stockpile somewhere and repair the boards yourself, but not every institution has time for that. So I'm a big fan of the eBay scavenge.
Yeah.
Well, I think for the most part, the self-reliant customer of a cell sorter or analyzer is a very small subset of flow cytometry now. And a lot of it is based on our background. But I think the large question that David brought up is, well, what do people do that they don't have funding and they really like flow cytometry and they use it as a tool? What do they do? I think they should look towards third party, reliable third party. And I think the rest of us should support that as much as we can. Maybe instead of trading in our instruments, maybe donating them to third party for parts. There's a lot of different things that could happen if we really had a mindset to support older equipment.
David,
Yes.
list all the third-party service suppliers you're aware of.
Gene Tools and Tony Ledger's I forget the name of it.
Alt
Yes. But that's about it. I was about to think we should build a list of all these, but
Indeed. It used to be, as you say, you could call Cytek for BD, you could call Cytoserve for Coulter equipment. As manufacturers close down their willingness to work, sell parts to these three-party people, they've disappeared from the marketplace, and it feels like it's word of mouth to even know any of these are there. It's great, but it's getting harder and harder for them to support instruments, especially when these instruments are being replaced by new models and there's not the saturation that you speak of. It's third party service is great if you know it exists, if they happen to cover the instrument you're interested in. But if you're a small institute, where funding is an issue, can you build your plan based on a theoretical third-party service agent? I don't know. I mean, I don't carry service contracts on most of my instruments, but as Bill cites, that's background. I have the experience to keep things running. But if you're a small university, not in a major metropolitan area, can you count on that? Is there going to be that sort of service available? I think the Purdue list is much more useful in that case, because you can give shouts for parts and someone may just have it in their locker. And I think you had cited that people aren't really self-sufficient anymore. That gets the background. That also gets to the change of how they're manufacturing instruments. Research instruments used to be open platforms. I think I'll throw on another laser. I need to do the word has slipped my mind. I need this special optics. I'm going to just strap it on there. And they're not building those platforms anymore. The legacy MoFlow was the last really open platform.
Tony Ledger's use of the company Voltron and the ability for him to adapt those lasers onto a lot of different platforms that were specific is actually pretty amazing. So that's the consumable piece that usually causes a lot of customers to say, okay, we're no longer dealing with this product because we can't buy lasers for it. But I think there's options there. And I'm going to divert this really quickly because there's another side of this too. When we're helping develop new instrumentation, when we're brought on as key opinion leaders, and Dave and I have been on panels for several different platforms being developed before, the one thing that I'm starting to say right now is you need to think about service now as you're developing the instrument. You need to have a plan for it, because a lot of it is reactionary, and there's no real forethought into how this is intended to be serviced. I mean, Dave and I were on development panel with a company that said that they were going to do nothing but remote troubleshooting, and that was going to work, and it was going to be wildly successful. Well, guess what? It wasn't, because they were doing a remote, and then all of a sudden there's a puddle underneath your instrument, and it keeps growing, but the people remotely can't see it. And then that's an emblem of that. But a lot of this is really incumbent on us as developmental help to these companies to make them a lot more accountable.
Can I ask a question here? And maybe this is a little bit devil's advocate, but when was the history of the Aria? I forget. When the first one was out in
2005.
2002,
2005?
Yeah.
2002,
Was it that early?
the
So
metal,
I mean,
yeah,
yeah, with those crazy gold nozzles.
and the evil left turn, the
Yeah.
show thing, yeah.
So what is a realistic support longevity that a company should, what would make you comfortable if a company said, we're going to guarantee X number of years of support for this instrument or this instrument line? What do you think that number should be?
Why you can't do that? It is
Well, there's got to be.
it's not within control. The biggest problem with Aria is the use of through-hole components versus wave-soldered components on boards. There are certain time points, milestones in the history of manufacturing that once you change and you have no more ability as a company to support that, you have to draw that line. You can't assign a number to that. But the thing that's not happening is it's not even allowed to go to that extent. These are tactical numbers that the manufacturers apply only to make sure that their new product is being sold.
Yeah, I'm just trying to relate it to like other industries. Like say your car that you buy, exactly. Or even well, I mean, cell phones is a little bit more of a commodity type thing. But I was just, recently Google released their latest in their phone lines, and which was a little bit of a story. They said, "Oh, we're gonna support software on this piece of hardware for 8 years," and the industry went nuts. Like, "Oh my gosh, 8 years! You can support this for 8 years," which to me didn't seem like. I mean, for a cell phone, yeah, that's probably nobody probably has their cell phone for 8 years. But just trying to see, like, if company X came out and said, "Here's our new instrument. We are going to supply or have service for this instrument for 8 years or 10 years or something like that." Because, right, the Aria platform is 20 years old now in general. An Aria 3, when did Aria when did an Aria 3 come out? So like 2012 or something like that. Even that's like 10 years now. So, I mean, I just want to make sure that we're not being unrealistic on the longevity of support. Is supporting something for 10 years or 12 years enough? And we should just say, okay, great. Or because of maybe the market penetrance of something like an Aria, they should be, maybe a little bit more generous with support of that over time. What do you guys think about that?
Well, there hasn't been an Aria. There has been an Aria 1, Watch Me Catch on Fire. There was an Aria 2, our fluidics are going to be fun. You're going to enjoy this ride. There was an Aria 3, hey, it works. So they haven't had to have 20 years of support for a particular instrument because they pulled those cords as they went along. I think most people plan on, getting 10 years out of their instrument. When I'm budgeting for a new instrument, I promise, the people handing out the money, this is going to last for 5 years, but I fully intend for it to last at least 10. And I think that's not a unusual expectation from instrumentation. There are issues that Bill correctly cites, changes in base components, through hole parts versus surface mount, that sort of thing. At which point, to continue support, they've either got to scavenge the marketplace for the corpses of old, or they have to redesign a whole new board using these new parts, which they could do, but do they have a financial incentive to do so when the cytometry market is, yes, how can you abuse us today so we can continue our work?
Well, there's an interesting point about when everybody's talking about Arias right now. The ACDU was FactStar Plus. Same ACDU was on Fusion. I mean, BD is the poster child of putting new skins on old stuff and carrying. I mean, the pulse processing that existed with the very first Diva Vantage existed in most of the Arias. It wasn't any different. And if you're going to do that, why obsolete only a subset of that when they all have the same components? That's my beef about the whole idea. If you know, in for a penny, in for a dollar. And they really need to sectionalize it to what they know they can honestly support. They can support 2U Arias with no problem because the components are largely the same as Aria 3.
Since the need for the instrument has not changed, it explains why you have an Aria 1 that essentially is very, very similar to the Aria 3. So it boggles my mind to that you should put a limit to the amount of support you're going to provide to any platform, really, like down to like what Bill mentions as the lack of parts, like the stuff is just not being manufactured anymore. It's unclear to me that there's a reason outside of just market control of the repair side of the business that
I mean,
That's something
it's
that Dave
probably,
and I have both experienced, both in our corporate lives and in our academic lives, is marketing. The problem with marketing having too much power in this whole scenario, where we've seen companies to where engineers had too much power in the company. There needs to be a balance from the manufacturing end to where they're fed what the features need to be from key opinion leaders. But then when they figure out what they want to market, they do it for the right reasons. They do it for scientific reasons. They don't just do it because they're going to sell more. And there has to be some true scientific empathy with the end result of a product that I really don't see as much as I did 15, 20 years ago. I see everything as just wanting to be disruptive and innovate everything, and even stuff that doesn't need to be.
right.
And that's marketing is driving that rather than just, I don't know, reasonability.
Well, yeah, I'd use a MoFlow legacy over a Bigfoot, like in a heartbeat.
Another reason they drop support on these older instruments is simply that there's not a company in the market today that staffs their service at the levels that it actually requires to be. They don't have enough service engineers either because they don't want to pay the salaries, or they, the work environment is not such that they can keep these engineers. So if you've just launched a brand new buggy instrument that people have just recently shelled out $750,000 for, you're probably going to send the service engineers there and not worry about the person that you got money from, 5, 8, 10, 15 years ago.
Yeah.
Which is where third-party service is supposed to take over. But again, I think it's an invisible field to most people.
If I understand what Tony Ledger said in the last podcast, running your third-party service engineer is a thing. It's like you need balls of steels and you need tons of support and it's just not an easy task. I don't know.
No, it's not. And it's really interesting as far as who is truly proficient in this industry as far as service. I mean, I'm gonna call the best thermo sorter engineer is a guy I worked with in 1993 at Coulter. And it's like, hold on, but isn't there anyone new? I mean, yeah. And before that, the only really good engineer they had was Matt Ottenberg's son, because he grew up he was spoon-fed from age 3 on working on MoFlows. So, I mean, what needs to happen is a technology transfer for the purpose of sustaining really high-end instrumentation, because the people it's going to affect the most are the cores in large institutions that are buying instruments that are supposed to do everything, because those are hard to maintain. And as we get more multiplexed, as we get more feature laden, they're getting harder to fix.
All right, we're 40 minutes in or so in this discussion, and I'd like to switch back to cell sorters, discuss platforms maybe. How do you want to do this? If I just start naming names, will you be able to say something about it? Does that
Sure.
work? All right. Let's start.
Well, maybe at least bucket them in like
Yeah. Okay. Good idea. So let's
high end, medium, low end.
Let's start with a high end. Where's the Bigfoot at nowadays? We discussed that already when it came out. Tons of problems. If you buy one today, where do you start?
Well, I'll pipe in. I have three. And actually, the first one I had delivered did everything it was supposed to do. It was a beautiful thing. The second one I had delivered was just a disaster from day one. But I've had the engineers out, the design team out. They have been surprisingly responsive up until they got everything working from the 100-micron point of view. Then they started hiring a bunch of new support engineers whose utility can be questionable at times. When I'm on a 100-micron tip, it does everything I expect it to do. Spectral is limited by the fact that I want to say Bill called it tree and branch optics.
Yes.
It really is designed, and so is the S6. It's designed to be a conventional sorter, but there's so many detectors you can get spectral utility out of it. So as far as spectral goes, yes, but it's not going to match an Aurora. The S8 optics are better in that regard. But when it comes to 70 micron, what I'm missing in my core, with the Astrioses going offline, with the Synergy going offline, is really a high-speed cell sorter, because the Bigfoot, for whatever reason, and it is, a MoFlow-like flow cell, I should say Astrios-like flow cell, does not do well with 70 micron. I can get 15,000 events per second with optimized concentrations and things, but I can do 10,000 with a 100-micron tip, and it's gentler at my cells. Why am I going to go through the bother of switching to get that very small increase in speed? Whereas with the 70-micron tip, I ought to be doing 25, 35,000 events per second without any problems. Plate sorting is beautiful on the Astrios. And yes, when it comes to 384 well plates, I still do single stream straight down, but the multi-stream 96 well is so fast, works every time. Oh, I love it. We have people who show up with 40 plates to sort, and we can just breeze through them and get deposition every time.
So this is R theta?
This is
Astrios R theta?
Yeah.
Yeah. So, I mean, that whole legacy of Cyclone, R theta, that is, as far as I'm concerned, the best plate deposition that ever existed. Again, we have a 22-year-old cell sorter that is the go-to cell sorter for plate sorting, which is really strange.
Yeah.
As far as Bigfoot and 170, here's another thing where a lot of the engineers they're in denial about, and that is the materials use inside a flow chamber. The reason why MoFlow did so well is everything was metal, everything was shunted to ground. There wasn't any absorbance of electrostatic energy in plastic, and we faced the same failure with the original reflection and Synergy. And we had the same problem with Bigfoot, and these problems were attacked in different ways. But really, it's important at the point of design to figure this out before you lock yourself into a 100 micron tip, never having tested a 70, never having tested a 50, even though you were offering it, and knowing that a 50 would have just sprayed all over creation because of the electrostatic energy collected in the chamber. And these are the things that if it's a high-speed cell sorter, it needs to be designed ground up. Last part of this, and I'll leave it alone. New engineers tend to forget history. I mean, this stuff has been banked and understood and things not to do in design anymore. But somehow these same mistakes are being made by multiple companies over and over, and they don't pay any attention to history.
If you're trying to replace an Aria, the logical place would go to S6. I've seen one. There's one in on my campus. I've never hear anything from it, so I'm assuming everything goes well. Do you have better experience with it? Anything you is basically an Aria? Is my take on it.
So I passed on the S6. I actually sat in on an S6 user group, and they spent half the meeting saying how bad the Bigfoot was about this, that, and the other. And then they spent the other half of the meeting complaining about things that were problems on the S6 that, had already been solved on the Bigfoot. If the S6 was sold as a conventional sorter and they hadn't put, I keep forgetting what they call it, sort step, when they messed with the ACDU, it would be a fine Aria replacement. It would be Aria 4. But it's a machine without identity because, it's DEVA based, but they're selling it as spectral. DEVA doesn't do spectral. You're using multiple softwares to try and get things done. The ACDU is with middleman, smart step, whatever they call it, is a disaster. So, if you don't need to do plates and you don't need to do spectral, the S6 works fine. DEVA, it's essentially the same thing it's always been, but we should have Rachel from Van Andel on here. She loves her S6 and she struggled with it, but she loves it, but she also doesn't do spectral on it.
Would you then go to see how I'm seamlessly moving from one platform to the next? This is
amazing.
Great hosting right there. Would Cytek cell sorter be a good fit? The beef I have with the spectral cell sorters is that, like I mentioned, the cupcake effect. This to me is like you're gonna buy a spectral based cell sorters to do spectral cell sorts, which I don't have in my facility. So I'm not quite sure how the instrument, how easy for these type of platforms to deal with like your typical 4-color stuff.
Well, what is
the marketing answer? It's a good sorter for what it's accurate. It works with multiple nozzle diameters. There's one thing that we can't ignore, and that's popularity. The popularity of Aurora Northern Lights method of spectral, it's permeated the entire market. And as far as market share of number of instruments, it can't be ignored. And all of these people are wanting to translate, and someone's got to do it. And I don't think it would be a poor business decision within an academic center to buy a CS, because there's always going to be use of it, because everybody wants to translate their 30, 40, 45 color panels, and you can't do it any other way.
But you can sort a single color on it as easy as any other platform, 2-color, 3 colors. A spectral sort versus a compensation sort at those low levels, all it means is you have to bring the proper controls to your spectral sorter. So you shouldn't be afraid of a CS just because it's spectral and you think it's a pinhole. A pigeonhole. There's nothing you can't sort on the CS that you can sort on a conventional sorter.
Dave brings up an incredible thing, is the fact that spectral somehow forces you into proper process, and that's been needed for a long time in conventional. And we've somehow fudged our way through conventional sorting for so long that I'm actually really happy that something forces you into proper process of panel design.
Yeah, yeah. I actually heard Cytek mention development in their software side that would make it easier to handle the single stuff, like the few color stuff where you don't really need to deal with spectral. So I don't know if that came out yet, or
I mean, they do have, like, even on the Aurora, kind of their what they've dubbed the virtual filter setup. But many times, if I'm just looking at one or two colors,
just go
I'll
with the
just
raw file.
I'll just take raw peak channels and make those my two channels and go with that. Yeah, I would imagine similar thing could be done on a sorter. So
Yeah.
Or just bring the controls, let it unmix properly,
bring the
and get on with your life.
Sure, whatever. S8. Let's debate this, Dave. My understanding is you need to slow down the rate of your cells to get meaningful pictures, and so to me, that will reduce your ability to do high-speed sorts.
So yeah, they don't even offer a 70 micron tip
Right.
on the S8. I can do with the 100 micron tip. I have done 8,500 events per second, which is, pretty darn close to, my jet and airs. The images, though, I mean, they're pseudo images, and they are, the equivalent of maybe 20x. So, the speed isn't really a major issue. From the tips I use, I get the speed I expect to get.
Mhm.
But the idea that the S8 is an imaging sorter is marketing fluff gone entirely awry. It's a very nice spectral sorter, where you can, produce you can, in theory, produce 3 channels of images. However, these are completely uncompensated images. So while there are 3 channels you can image from, if you're doing multiple colors, you really have to be careful with what you're using, or your images are going to be skewed a bit, shall we say. So I tend to think of it as a spectral sorter with 2 imaging channels, because I can, usually spread things out well enough with that. And I get as good an image, going at a few hundred events per second as I do 8,500 events per second. But again, I'm a solid tumor sort of location. We live on our 100 micron tips.
Right.
We have used the 8,500, but not really pushed it to its limits yet to test that. Data management becomes a problem when you start collecting your images, though. So
can you expand a bit on, like, if the imaging is not going to be all that useful down the line, can you expand a bit?
Well, I find it very useful. And in fact, just the other day, we were doing a sort for someone on the Bigfoot, and they were getting a lot more variance in their MitoTracker, not MitoTracker, the lysosome one, whatever the heck it's called. They were getting a lot more variance than they expected to see. Biologically, it didn't really make sense to them. So they were wondering, is it a lot of debris or something like that? And it's like, okay, well, let's solve this problem. Let's plop it on the S8, and we can see exactly what all these populations are. And we saw the same variance, but now we're able to tie it down to these morphological features. So it was very useful. The reason I bought it was, for years I've had people saying I need to sort cells that have platelets attached to them versus cells that have taken the platelets in. We can lie to them and tell them that, oh yeah, we'll look at the signal width and be able to figure that out. But no, whereas it becomes trivial on the S8. So it's a very useful feature. But if you're buying an imaging instrument, you're not buying the S8.
Right.
So you can do localization and
absolutely
by that resolution.
Yeah.
See, I mean, that's a huge benefit.
So I guess point taken. I guess I just wanted you to expand a bit on the spectral side of things. Like, everybody talks about the imaging, but it seems spectral is done really, really well. What's different about it?
Well, I mean, the optics aren't quite as tree and branch as on the Bigfoot. It doesn't, like the CS, it doesn't really have a conventional fallback mode. It does have raw mode, so as long as you don't need to compensate too much, you can fake it. But the unmixing algorithm hasn't failed on us yet. We're getting really nice unmixing. The software, I did not expect to like the software because I'm a research guy, and these wizard-based softwares, make my skin itch. But it's not locked down as much as previous wizard-based softwares have gone. And it really is as simple as draw your gate, run your controls, draw your gates, and it unmixes without long delays and does a really good job so far every time.
Cool.
My understanding as well is this isn't a series of plugins to do this. This is one contiguous software activity. Yep. I mean, that in itself is not what I'm used to out of that company.
Yeah, they do have the ability to draw things in through FlowJo. And then if you want to play with the images afterwards, there's a bunch of plugins to create TIFFs, and then a plugin for FlowJo to read in the TIFFs and that sort of thing. But the actual operation of running on the sorter is just one smooth piece of software. Now, there's lots of choices in that software I could wax poetic on the stupidity of for quite some time, but nothing's a showstopper. Nothing is overly irritating. It just seems to be a smooth operating procedure.
Nice. The other player in the spectral field is Sony, and just today I got an email from a vendor that's mentioned that the FP7000 has been announced, which is going to be there. They 6 laser, 160 something detectors. They dropped the far red laser, which I suppose wasn't doing much for anybody. So, any hopes and dreams for that instrument?
Well, I'm hoping it's not a chip sorter.
See?
I mean, the one thing that upset me, because I was in development with Gary Durack over this, from reflection on, and I actually have the first chip on my wall here that was ever produced. But there was a different motive to create a consumable product for cell sorting, and I wasn't all that happy about it. That and there were performance limitations of that chip that you couldn't do in high end. I'm just hoping that this is going back towards finishing the Synergy project, finishing that and making a high-end sorter. So far, I don't have any information to define that, but that's my hope.
Yeah, looking at the image they sent out with it, it looks like an ID7000, and on the sorter half, oh, that's the exact same collection device from the MA900, and that door is the exact same door. And oh, this is going to be a chip sorter, isn't it? That's disappointing.
Yeah, agreed. Now they could use those housings and put a nozzle, a ceramic nozzle in there. In fact, as they talked about doing that. But my biggest issue with MA and with SH was collinear lasers. I mean, that's something that I don't think should have existed, past 1990.
Right.
And so, over engineering, making the simplest tasks prone to failure. So.
Well, that's Sony, so can't really fault the biology group for that. But yeah, reading through their specs though, I don't know. I mean, do the other chip sorters do this will do 6-way sorting? It has all the nozzle sizes. I don't know. Just something about it doesn't seem like a chip sorter to me. But
well, if it's not, they can take my money.
Well, and you did say earlier, right, that the ID7000 was one of those ones that kind of just worked without problems. So maybe there's hope that a sorter companion to it may fare similarly. Although, right, I think now they're saying autumn 2024 on their press release here.
And I'm surprised that they would say something that far ahead. Well,
I mean, it seems like the ID7000 took forever to get actually out as well. But I don't know if maybe that's with the experience of the S8 and the ID7000, maybe that's a good thing that it has this long incubation period, and maybe those have fewer fewer problems coming out the gate, like we were referring to before?
My experience with Sony since it left Champaign, Illinois, is that there's a lot of pride and honor in their launch, that I don't think that they would be willing to launch so egregiously early that you'd have 3 years of development after launch.
All right. So is there anything else I'm missing in the high-end field? Because then I'd go medium field, and I guess we kind of covered Sony. The chip stuff is not the greatest.
Yeah, I mean, the CS I consider a mid-range sorter, but buy one, they're swell. The chip-based sorters, when I got my SH800, I still have it. What it's supposed to do, it does well. So we got an MA900 to replace another sorter, and just starting it up in the morning is fraught with peril. Because all this over engineering, they decided, well, the SH800 works, let's make sure the MA900 has more parts to do the same job, and it fails time and time again. So if I'm a small institution with a limited number of sorters, I'm probably not going to be willing to invest those dollars in an MA900. Someone feel free to disagree and tell me I'm talking out my ear, but
I'm telling people to go for a wolf sorter before they do an SH800. I mean, I know they're going to be sorely limited on parameters, but as far as what you get out of it and reliability and all that, I mean, that's what they want. And there's a lot less headache involved with that.
Yeah.
We went with the Tyto. We brought them both in, but since we could only afford one of the lower pressure sorters, we decided the Tyto was the better package.
Well, I agree. But that's a pricey proposition. And that's for what you're getting. The multiplexing's not really there, but all the benefits of microfluidics are.
And it has cooling now, so that's a perk.
Yeah, I think if it's allowed to develop to its complete fruition, and we have a microfluidic sorter that has a lot of colors and lasers, for me, I think that's game over. And as long as on top of all that, you have a true spectral idea and not just a branch and tree optic system that can do spectral, but something that can actually do the purity of spectral, I think that's game over.
Mm-hmm. So that's the future of like a Tyto-like platform, or?
I don't know about the world's fastest valve, that MEMS device taking over, because remember, it only sorts one way.
Yeah.
And there are other designs being considered that are multi-way sorters.
Mm-hmm.
I just think that this microfluidic idea has to be allowed to develop further.
Mid-range instruments, CytoFlex SRT. We demoed it, and I thought it was fairly nice, very easy to use, works well. Yep.
It's just hard to buy a Coulter instrument, seeing how they, pushed the Astrios, then Danaher came in, and, I wholly blame Danaher for this. But the stepping away from the high-end market that they had just built,
right,
leaving everybody hanging, it's a hard choice to buy a Coulter piece of equipment.
Well,
but that's my bad.
Danabots told them to, and they do whatever the Danabots say.
Yeah,
but it works. It sets up easy. It works easy. I mean, it's a fine piece of mid-range kit. When you buy it, it's all it's ever going to be. It's not expandable in any sort of way. But if you need to do these 6-8 color sorts all day, every day, it's fine.
Yeah.
And Coulter at least supports the CytoFlex platforms and seems to do a reasonably good job of it.
Yeah.
You can drop one off of a 3-story building and it'll survive.
Ooh. Challenge
I've been
accepted.
tempted to do that with some of my instruments sometime, just to test.
Their packaging engineering has been really superb on that platform.
What else am I missing? Like at this point, what's left are the fluidics instrument, the Tyto,
There's a
these smaller
lot.
device that do single cell deposition in 96 well plate, that type of stuff.
Yeah, you're getting pretty specialized at that point. I mean, who is it? Nodexus with the NX1.
Yep.
That's a cool little, cartridge-based instrument. All it does, it has a couple colors, but its goal is to absolutely sterilely and viably deposit into plates or tubes. It's not particularly fast, but if you're developing cell lines and that's all you're going to be doing, seems like a very nice choice. Throw on a GFP and a viability marker. Throw in your plates, throw in your tubes, it'll get you there. And it's cheap. So, that, and there's lots of instruments like that available, all with various limitations. But, if you have a good idea of how you're going to be working and only have, a few bucks to spend, there are a lot of these lower end niches that, you can scope out and maybe find something that fits better than buying a CytoFlex or a CS or something high end like that.
Yeah, I feel like it
I have
gets
a lot of
tricky
hope
to.
for Nodexus V2. I think that's going to be a real good choice, low end.
I feel if you're gonna get one in your core, you need to like have really good. You're gonna buy it with the specific purpose in mind, and you need to have really good relationship with Genomics Car and all these other people where the cells are gonna go, so that everybody's on the same page on how you do things.
I've been looking a lot at these types of platforms on the lower-ish end for two applications, like I mentioned earlier. One is just making cell lines, which any of those, like we did the Namocell, we've done the Wolf, we've done. I'm familiar with the Nodexus platform, etc., which are really good single cell deposition units for the most part, and all have some capacity to do like bulk sorts into like an epinorph. But that part of the application seems a little bit underdeveloped, because it works for bulk sorting, but it's so slow in terms of throughput of cells, that unless your sample is already like 50% positive, you're going to be sorting for hours just to get enough cells to put into 10x.
Yeah,
right? And that's really the application that I'm
right.
Like, if there's an instrument that did both good single cell deposition and could do like an enrichment of TILs from a tumor for single cell. Like my favorite instrument for doing enrichment of TILs from a tumor is a Tyto, but of course that doesn't sort into plates. And then one of these little boxes to sort cells into a plate. But then I got to buy two instruments.
Yeah,
and
the Wolf has the plate option.
Yeah, right.
Its chips are a little, drippy for me, but I'll probably end up with one because we do so much nuclei work to, AGC. And I don't want to have a fleet of Tytos because they're expensive. They're unidirectional. A Wolf would be a nice fit, but, probably a Wolf in a hood.
Yeah.
So I've got a weird question for any of you that have played with these so far. Which would be a choice for the infrequent use? Because, as far as I'm concerned, all cell sorters suffer from atrophy. If you leave them on a shelf for over a week, something bad's going to happen when you try to start it up. But the thing that intrigues me about the whole microfluidic design is that seemingly you could have something that you just call upon when you need to. And it might actually be okay in quiescence for a little bit.
I know.
Yeah, but I think, because they don't have a fluidic system, essentially, right? It's fully enclosed in that chip. And so if you don't have a fluidics, that's like 90% of your problems disappear automatically from your sorter.
So
Yeah.
resounding Tyto.
Yeah, I mean, even the wolf, you've got fluidics to deal with, and if there's fluidics, there could be crystallization, stuck valves, that sort of thing. The Tyto, just drop in a cartridge. It doesn't care if the last cartridge was dropped in an hour ago or a year ago. It's as stable as any other computer, assuming your lasers fire up.
In industrial settings, in people that are doing antibody development, things like that, those are considerations as well. Because you've got these companies that don't sort every day, and they might not sort every week. And
I think my beef on the Tyto, and this is something that you, Bill, told me it's a drink thing that Milton organized, and I was presenting the instrument, and you pointed out that there's no QC protocol per se on the instrument. So if you run a sample and data looks weird, you're going to assume it's the cartridge, you're going to assume it's the sample, you're going to assume all kinds of things, but you won't have a tool to say what's going on exactly. So you don't, they still need to develop some kind of either a QC cartridge that you can reuse, run beads, and make sure that the machine's running properly, stuff like that. Because otherwise, the solution happens to be you take your sample, run it in a different cartridge, and then a different cartridge, and then $700 later, you're like, okay, maybe it's the machine. I'll call tech support now. So
we just keep a dirt cheap CytoFlex sitting next to it. So if anything looks weird, we can pop it on another cytometer and no, it's not the sample.
Right.
And then,
well, I really think the Tyto, as long as it has been in development, when you really think about that it was Jack Dunn's mindchild a really long time ago. And Stefan Miltini's only answer to that was, let's stick a max quant on it. And my thing is that I'm not a huge fan of the max quant. I mean, that's my only sticking point with that platform. It isn't the microfluidic aspect of it. I think Jack Dunn did a bang up job, but someone's going to have to talk me into really liking a max quant.
Yeah.
Nobody's going to do that.
I sold mine off.
Yeah, right. I mean, so theoretically, a Tyto-like machine with all of its benefits, with a better optical system. And, I'll put in my plug. I mean, I've never looked at this instrument for real, but I always think it's such a neat idea is that I think it's called like a gigasort or something like that. It's microfluidics based, but it does it in a ton of parallel channels. So you get the
Cytonome.
Yeah, I think John Sharp's technology. So it just seems like, if you needed, so it has all the same benefits of microfluidic sorting, right? But the problem, even on a Tyto, it's somewhat limited by throughput, even in their high throughput cartridge and mode, right? But this would be, you want to do 100 million cells. This thing splits up your sample and runs it into, I don't know how many channels they have it running through, but and it makes sort decisions on each of them independently, but I believe that it has like shared lasers and optics and all that kind of stuff. And I don't know, I think the parameters, fluorescence parameters are probably somewhat limited as well. But yeah, I mean, stick an idea like that with a spectral solution on the fluorescent end. You could do like high dimensional, super high throughput, very gentle cell sorting. Well, there's another technology I'm kind of sad isn't here with us anymore. Bennu Bio is apparently no longer in business, and the whole idea of exploiting acoustic focusing to the point where you can get multi-channel, not gigasort-esque necessarily. I mean, John Sharp has always been known to either go big or go home, and but 7 different sort channels that are acoustically driven
That was an idea that I was really hoping would happen. Does anybody really know the final disposition of what happened to Stephen Graves?
Yeah, I don't.
I think they just fell off the map. That's sad.
All right, we need to end on a cheerier note. So somebody bring a topic.
Okay, I've got another sorter that I'll throw out for contention here. The Deepcell platform.
Hmm.
You guys see this at Cyto River? So it's all imaging bright field based, microfluidic based, chip based, and will use essentially, the buzzword of the day, AI, to analyze all these bright field images and do six-way sorting essentially. And at first I'm like, kind of like a lot of these imaging type things, like how useful can it really be? Until I talked to somebody who's like cell death expert, and they said there are so many morphological cues in and on the cell during various different types of cell death. So not just like apoptosis and necrosis, but all the other crazy types of cell death, and even like senescence, things that are associated with it, that people in that field rely heavily on morphology, and they don't really care about fluorescent markers. They don't care about your Nexin-5 and your PI staining and stuff like that. They just want to look at the nucleus and chromatin condensation and other things, blebbing that happens at different stages, and they want to sort cells based off of that. Different stages of pre-death that might actually give you a lot of information from a platform such as this.
Yeah,
I thought that was pretty cool.
That's speaking the clinical language, the medical research language, which is not something Flow necessarily speaks. Tissue people versus Flow people have very, very different mindsets. So it's interesting to see an instrument that's coming at it from the other end of things. And I've seen some interesting talks, but they've all been Deepcell sponsored. So,
well, they add one more thing to that. Menarini bought out Silicon Biosystems in the DEPArray, and the DEPArray is an interesting instrument by itself. The pheresis travel, and it's excruciatingly slow, but it's also that accurate, and you have all of your imaging that you would ever want, plus some fluorescence. And other than it being really slow, people have had a lot of success for single cell work. Really, really high accuracy, and it's not that expensive.
All right. Well, thank you all, guys. I think we'll stop here. It's been great having you on. And to our listeners, thanks for joining us, and leave comments. It's a lonely place out here on YouTube. If you want to ask questions or anything you want to know about cell sorters, let us know, and we'll talk to you guys later.
I don't feel lonely.